to swap between bands with antennas that were already set up for the bands where we wanted to go. And I got my first test or experience at handwriting a Cabrillo file. There you go. Next. The last thing I wanted to talk about here is the Collins 233D restoration project that's going on over in Building 120 in the old Thank you. Com Central transmitter room. It's bigger than those 2 syllables. And that work has been going on now for some time, and we've been actually making some pretty good progress lately. So our latest efforts were where we got a lot of signals verified. What we had here for the past couple of months is that we think we've gotten all the signals from the control tray over to the exciter, but weren't sure why we weren't getting any RF power out of it. So what we have recently verified is that we've got audio all through the audio amps on the control tray, as well as the keying signals and the bias are there. Just the oscillator isn't starting up. So we have we now know more than we didn't know before, and we're zoning in on that, and we're hoping by sometime this summer to actually have RF out of this beast. One thing I wanted to mention is that the auto tuner, which is in 3 separate decks, all driven by a 3-phase motor, are connected together by a series of linkages. And when we purchased this transmitter, most of those linkages were missing. They'd gone to the who knows where. And I just want to mention Don Grimm, retiree from Collins here, who machined all these linkages from scratch. And if you ever get a chance to get over there and look at them, they are gorgeous. They're all machined out of stainless, and he did a really bang-up job on it. And if you're looking to do some work where low voltage is defined as 208 volts, get a hold of Jim Jones. And we have a regularly scheduled work hour at lunchtime every Wednesday, which coincides with when the museum is open, so come on over if you like. Next.
I had a question on 233.
Yeah.
What's the MBOF?
Okay. Yes. Well, one of the things that enabled us to interrogate these signals between the various chassis was the MBOF, which is an acronym brought to light by Jim Jones. It's the mic breakout fixture. So what we had going on for a while was it was a series of trials and errors, and so we hit the dial, the auto tune dial, and we'd get what sounded like the right number of clicks, but we weren't sure. So we turn up this pod. Well, that sounds better. No, it's not going back. We had no idea whether we're going the right way or not, whether our signals are the right amplitude. So I had this different idea of like, well, why don't we put a fixture in so we can actually break out these signals and monitor them live. So that's what the MBOF is.
This mic is in mic unit, not microphone.
Right. Correct. Next. And gets it next.
Jim, should take this. Come get 2 microphones over here.
Cheap and twice the price.
I need to use both of them?
Yes, you do.
Yeah.
That's for us. This is for posterity.
Oh, Joe.
Oh, I'll pass this around. If anybody hasn't signed up for a club polo shirt yet, I'll pass this around. And on the back, you can just start here. Name, size, what your call sign is, and our contact information.
Okay, I'm a stand-in for Greg. Last weekend, we worked on some antennas, and before I get into the antenna work for field day, we'll talk a little bit about it. Most people know it's the last weekend in June, and we're going to, it starts on Saturday at 1800 UTC and ends, that's noon. And, okay, 1 o'clock daylight time. And ends 4 o'clock on Saturday. The total operating time is 27, and we're going to start our setup at
We're flexible. The computer's having a problem.
okay, on Friday, and I believe that's at 7 o'clock, correct?
Evening, right.
Okay, and it's at Hiawatha Clark Park. It's open to all hams And also it's open to non-licensed people to operate get on the air station under the supervision of licensed operators. Now, let's go to the next slide. What our objective is 26A. That's operating 26 stations. To be listed as Class A, all contacts must be made with transmitters and receivers operating independent of commercial mains. 20 plus transmitters maximum are eligible for a bonus of 2,000 points. And the question is, why do 26A? Well, because we can. And we want to give W3AO a challenge. They've been the big gun on field day for operating. It looks like the record here is 28A, and 26A sounded nice. And we want to win on not only on number of transmitters, but have the points. So we're looking at a strategy that involves, let's go to the next slide, how to get on greater than 20 stations, how to get 26. Well, we're going to do 3 modes per the normal pre-work bands, CW, digital, and sideband. And we're going to look at getting the station on 160 meters, then a bunch of VHF, UHF stations, and Greg is hoping to find a light station, that is a visible light station. There are bonus stations that don't count towards our transmitters, and we'll operate some of those on VHF, UHF. We have a get on the air station, a satellite station, and a PR station that should give us 3,400 points. Okay, let's go to the next one. We need QSOs to win, so we need a station captain for each of these bands. That will involve organizing, coordinating all of the equipment for that band and the people also. It will, and I would suggest in addition to a station captain that you have an adjutant or assistant to back you up in case in case something happens and you can't make it. You can have the fruits of your efforts realized even in the event that you get distracted. So there's a checklist here that involves the radios, the accessories for the radios, power, and build your antenna. And the antennas for this particular effort are going to be a challenge. What we're going to try to do is use narrowband antennas to help eliminate the intermodulation interference and overload of your front end of your receiver by the other stations. Basically, we have started a design for that, but getting back to the checklist here, you also need to have your own shelter and table and so forth. Here's a picture of a ground fault interrupter that is listed on Amazon for 32 bucks. Next slide, please. Okay, we have the criteria for a field day that all equipment, including antennas, must lie within a circle of 1,000-foot diameter, and we're also going to be operating independent of the mains, so we'll have a power distribution system or multiple generators, solar power, wind, whatever. We our base unit we have committed is a 17 kilowatt diesel. Okay, to reduce intermod, we're going to look at using this magnetic loop type of feed for loop antennas. This 1 meter diameter antenna can perform as well or better than many antennas other than a beam. The bandwidth can be as low as 10 or 20 kilohertz, and this website here has the design from which we deviated in our design. This picture shows the feed loop. This is a magnetic coupling loop that's not as clearly illustrated in these slides. The magnetic loop is basically a coupled inductor. We're operating the little loop and the big loop as a transformer, and the coupling coefficient is the impedance matching part of it. And let's go to the next slide. Once we get them together, we'll see that the big loop is the resonant part. This is a construction that we did last Saturday for a 40-meter loop. We made it from common construction materials. On the 40-meter loop, we used a center hub of wood and these electric fence post connectors. And we used as an outer ring or rim a plastic irrigation pipe. Let's go to the next slide. Aluminum sheathing, aluminum flashing is connected to the pipe by using self-tapping screws, or actually driven with hex head driven into the pipe at about 1 foot spacing. There are 2 of these rings that provide physical support on the edges of the antenna. In this picture, we can see the beginnings of the capacitor that forms the resonance with the inductance of the loop. Next slide. And this is the finished product right here. You can see the capacitor on the left side here. We've adjusted that, and we have it hanging so that the weight of the capacitor itself keeps itself aligned and allows water to drain through it when it rains. You can see the magnetic loop here that is the primary. The inductance of this loop is lower than the large ring, and it provides, via the coupling coefficient, the impedance match to the low impedance radiation resistance of the loop itself. And here is a detail on the left of how the capacitor looks from the outside, and you can see how acrylic, sheets of acrylic plastic that are available as a common building material are inserted in between the aluminum butterfly plates of the capacitor. Next slide. Did someone have a comment or question? Okay. To test it, used a BNA 2180 vector network analyzer. And at this point, we'd actually done the network analyzer, and we're actually loading it up. And it loaded up very well. And the watt meter would confirm that, yes, it did accept 100 watts of power with negligible reflected power. Next slide. On 40 meters, we got a minimum SWR of 1.05, and at this particular tuning, it was tuned to 7.08 megahertz at about 7,200 kilohertz. We're at about SWR 6 to 1, and when we tune him down just a little bit lower, like in the middle of the lower 50 kilohertz of the band, we're pushing a 10 to 1 SWR at 7,200, which will provide a fair amount of attenuation for intermod. The other traces on here may be of interest, and these pictures and the test results are actually posted on the website that a Google group that Greg has set up, and my memory.
They can add them. If they want to get added,
Yeah.
just come inside.
Next slide, please. Okay, and then we did the 40-meter loop on Saturday, and then we figured that we had enough daylight left, we'd just do another one. So we built one for 20 meters. Let's go to the next slide, please. And this one we tuned for the sideband portion. And we can probably get this much lower by adjusting the magnetic loop just a little bit. And basically, the area of the loop is what you adjust to adjust the impedance match. It can either be done by changing the area of the loop in parallel to the plane of the loop or rotating the loop.